Hey guys, welcome back to another video in our N-body simulation series. So we're almost finished. I have to tell you that. The only major thing that is missing right now is our Quadtree, which is the major player in our Barne's hot algorithm, right? So, so I want to start off by defining our insert function where we insert a body. And this is definitely the most trickiest one in our Quadtree implementation, so just take it slowly if you don't get it. You can watch the slides again that I showed you before where I explained it, and yeah, you'll be fine. So at first we want to see if this Quadtree contains the body. That means, does this Quadtree or the bounding box that this Quadtree represents, is this body inside? And as you know from the last video, we defined a function in our bounding box that we can use to implement this. So we just call celestial body here, call bool. Then we return body dot inside bounding box. Note this function does not exist yet. Okay, this one inside. We will need to do this right now. So let's go back to celestial body here and just create a function called inside. One moment. Inside with the bounding box as a parameter, and now right here we can call the bounding box dot contains position. Okay, and now when we build it, it should give us no errors anymore, and we're all good. Okay, so now we check if the body is inside this bounding box, and if it's not, then we just ignore it. I'll just add some comments here. Returns true if the position of this body is inside the bounding box. Inserts a body into the Quadtree. Okay. So, if you can remember, there's some things that there's some cases that I mentioned before in our Quadtree that you need to know and implement. So let's start off by saying, okay, is leaf? That's one case. Otherwise, that's another case. So if it is a leaf, what do we do? If the body or self.body, so this body is nil, that means nothing is inside the leaf. We just can say this pseudo body is the body itself, and this body is the body because nothing is there, right? Otherwise, if the body is not nil, there is something here, that means we have to split it up. We're at the leaf, but there is a body. Remove the body and split this node into 4 children. Then insert the old and new body into the correct squares or quadrants. Okay, so let's start by doing this. Old body equals to self.body. We can unwrap it here, force unwrap here, because we know it is not nil, so it's safe. Okay, but normally you wouldn't want to forcefully unwrap an optional. And we just say self.body equals nil. So that's our way of removing it. And the pseudo body is body dot create pseudo body with old body. As you know, this is the function that we created in the last video, and I'll use the fact that we use the new body and old body. You know what, I'll just do it, I'll just, for the sake of clarity, I will just call it new body cause body. So let's call it like this, okay? And now we will have a function called compute Quadtrees. I'll call here compute Quadtrees, or compute new Quadtrees actually. And this means that we compute the new bounding boxes. Computes the new Quadtrees for this node. And you will just type in southwest equals Quadtree the bounding box dot southwest. That's what we defined in the last video, and we'll do this for every other Quadtree node or subtree. That's it. That's simple, right? Nothing too crazy here. Oops. And that's how we create our new Quadtrees. Now we just need to reinsert the old body and the new body into the correct quadrants. And for this, I'll just define a function. I'll just call it private here. Insert node body celestial body, and this is where the quad position function that we wrote before really comes handy. So we just say body dot quad position Am I right? Is it called quad position? Oh, sorry, I forgot. We need one more function in our celestial body called quad position. In bounding box, and it returns an integer. We'll just return bounding box dot quad position for vector position. I forgot some comments here. We'll just comment it real quickly. Returns true if this body is inside the bounding box, and here returns the correct position index, let's say, for this body inside the bounding box. Okay, now let's go back here to our quad tree and call quad position in our bounding box. And now we just check if position equals to 0, then southwest dot insert the body. Now you can see that this insert is recursive because we have to go down one layer or one subtree to insert it into the right position. And I suggest you really take a look at recursion if you don't understand it right now. But as I said before, this is not a beginner video, so I won't go over detail in how recursion works. Okay, 0, 1, 2, 3. Just fill it in. And if you're wondering why northwest for 1 and southeast for 2 and so on, just go back to the bounding box here, and you can see the position and associated data with it. So 0 is southwest, like this, and so on. Just take a look at it. It's simple. And now I just want to call insert node here, old body, and new body. Okay, that's it for this one. And now we want to cover the fact that this is not a leaf. What does this mean? If this is not a leaf, then we have to do two things. We have to update the center of masses, because we add a body, right? If we add a body to the quad tree, then it will change all the center of masses of the subtrees, right? Because now it is an extra body, and it will change the center. It will change the center of mass. So we have to account for this, and by doing that, we call this create pseudo body function again, and use the pseudo body to add it onto our pseudo body. Yeah, that's how you do this. You just add this body and create a pseudo body again, and recalculate the center of mass. And again, this is not a leaf, so we just reinsert the body into the right quadrants. Okay. I think this is pretty much done right now. The only thing that we have to do now is we need a function for updating the force, because our force right now, if we try to run this, the force is not updated in our bodies. So we call update force, and this is where the algorithm, I'll just copy and paste this comment right here. Okay, because this is where the algorithm actually shines. If it's leaf, if it's a leaf, and if the body doesn't equal to body, and the body is not nil, well, then we just calculate the force on the body itself. You can just force unwrap here, doesn't matter. Otherwise, if it's not a leaf, but if the bounding box dot half length, oh, I'm sorry, we'll just put this here at, let's go back to the bounding box and call private set here, because we need to access it, but we don't want to destroy the data hiding concepts behind it. Okay, so we call half length times 2, so that's the actual length of the bounding box, divided by the body dot distance. And this is another function that we need to implement that I forgot. Let's go back to celestial body and call distance to body, celestial body. Now return distance or position dot distance to body dot position, and this will return the Euclidean distance between two bodies. Okay, now we call it back here, call distance to self.pseudo body, because we are not at a leaf, and we are at, and we can check if it's smaller than simulation dot theta, or let's define theta here in this. Well, no, let's call it simulation dot theta, like so. And let's go back to simulation and call it a variable theta double equals 1, and just call controls the accuracy of the Barne's hot algorithm. And if that is true, then we just calculate the force from this pseudo body. Okay? Otherwise, if it is not the case, if nothing of that is nothing or no condition is met here, then we just go further down the tree recursively and go further down the tree until we hit the point where one of those will eventually work, or will eventually be met, or a condition will be met. Okay? Just have to do the same thing for the other ones. Northeast here, southeast, northeast. Okay guys, so far we're looking good. Oh, these are some space errors here, but I forgot to call this function recursively inserts a body into the right quadrant. Okay, bye. Okay guys, so that's it for this video. The next video will actually be the last video, so we are progressing very well. Our Quadtree is almost set up. We only need 1 or 2 more functions, but nothing too crazy. Our main functions are here. We are calculating the forces correctly, and yeah, that's it for me. And if you have any questions or any topics you want me to cover, then please let me know. Otherwise, thank you for watching, and I will see you guys in the next and final video. Bye bye.